So, hi guys. Today I am going to discuss about calculation of doses, and I am going to show you here different sample problems with their solutions and of course with the answer. So before I start, by the way, I'm just going to give 5 problems. So before I start, I'm just going to say that calculation of doses is a skill that all medical practitioners should practice and of course master. However, it is because first and foremost it involves mathematics, which I think most of us find it really difficult, like me. But we need to put focus, and it should be done accurately in order to avoid certain consequences and life-threatening conditions. So I'm just going to share it. So let's move on with problem number 1. So problem number 1 says that a patient has been instructed to take 15 ml of alumina and magnesium oral suspension every other hour for 4 doses daily. How many days will two 12 fluid ounce bottles of the suspension last? So in here we are going to identify how many days will two 12 fluid ounce bottles of the suspension last. So the given, we have the dose, which is 15 ml, and it should be 4 doses daily. So we need to multiply it by 4, and it will yield to 60 ml, which is the size of dose daily. And then we also have here the given, which is 2 12 fluid ounce. So we need to multiply 12 by 2. So 12 fluid ounce times 2 is equals to 24 fluid ounce. And since we notice here, we have different units. The dose has 60 ml, and here we have fluid ounce. So we need to convert fluid ounce into ml. So 1 fluid ounce is equals to 29.57 ml. Then 24 fluid ounce times 29.57 ml over 1 fluid ounce is equals to 709.68 ml. And that is the total volume of the 2 bottles in ml. Then we move on to the question. How many days will it last? Since the given here is 709.68 and 60 ml, we just need to divide it. So 709.68 ml divided by 60 ml is equals to 11.8. And since we are looking for days, it should be in a whole number or in a discrete data, and that is 12 days. So the answer here is 12 days. 12 days. Sorry for this. Okay. So 12 days. Next, we move on to problem number 2. So the question, if the daily dose of a drug is given in the literature as 8 milligrams per kilogram of body weight or 350 milligrams per meter squared, calculate the dose on each basis for a patient weighing 150 pounds and measuring 5 feet 8 inches in height. So we need to calculate 2 bases. The first one here, using the given 8 mg per kilogram. So the given here is the weight of the patient, which is 150 pounds. Since the dose here is in kilogram, we need to convert 150 pounds into kilogram. So here, so 150 pounds times 1 kilogram over 2.2 pounds is equals to 68.18 kilograms. Then we move on to the solution of the first basis. Again, first basis uses 8 mg per kilogram. So in here, it is just kind of direct. So we are going to use ratio and proportion. And since it is ratio and proportion, it should be cross multiplied. Okay, and then just substitute 1 kilogram times x, here, 1 kilogram times x is equals to 8 milligram times 68.18 kilograms. And then after that, we need to divide the both sides into 1 kilogram in order to cancel out the kilogram, since we are going to find those which is in milligrams. So 1 kilogram times x over 1 kilogram is equals to the answer here, 545.44 milligrams per kilogram over 1 kilogram. So we are going to cancel out all the kilograms. And the one left here is the mg, which is 545.44 mg. Okay, so the answer in the first basis is 545.44 mg. And then we move on to the second basis using 350 mg per meter squared. So the given here is the height, which is 68 inches, and the weight, 150 pounds. Since it is in meters squared, we are first going to find the BSA. So, given is in inches and pounds, we are going to use the type A exactation, which is S is equals to square root of I times P over 3131. So just substitute 68 inches for I. 68 times P, which is the weight, 150, over 3131 is equals to 1.80 meters squared. And then this is the BSA. Okay, sorry, BSA. Sorry for the brain. Okay, so then we are going to multiply it over the dose. Here, the dose, which is the 350 mg per meter squared. So 1.80 meters squared times 350 mg over meter squared. And then we're going to cancel out meter squared. So multiply 1.80 times 350 is equals to 630 mg. Okay, so again, the answer in the first basis was 545.44 mg, and in the second basis, it is 630 mg. So I must say that it is, I think, much useful. The second basis is much useful because BSA is included, and I think it is much more accurate and precise. The dose is much more accurate and precise. Okay, move on. Let's move on to problem number 3. It is also same as problem number two. So, the daily dose of diphenhydramine hydrochloride for a child may be determined on the basis of 5 mg per kilogram of body weight or on the basis of 150 milligrams per meter squared. Calculate the dose on each basis for a child weighing 55 pounds and measuring 40 inches in height. Okay, again, we are using first and second basis. The first basis using the given 5 mg per kg. Weight of the patient is the given one, which is 55 pounds. And since the dose here is in kilograms, we need to convert we need to convert the 55 pounds into kilograms. So here, 55 pounds times 1 kilogram over 2.2 pounds is equals to 25 kilograms. And then we go to the solution of the first basis, which is again ratio and proportion and cross multiplication, and just substitute. 1 kilogram times x is equals to 5 milligram times 25 kilogram. And then divide both sides by 1 kilogram so that we could find the x. We could find the x here. So 1 kilogram times x over 1 kilogram is equals to 125 mg per kilogram, which is the answer here, over 1 kilogram. And then cancel out all the kilograms. Cancel out. So the answer is 125 mg for the first basis. And then second basis uses 150 mg per meter squared. And since it has meter squared, we are going to find the BSA. So the given height, 40 inches, and the given weight is 55 pounds. So again, we are going to use the type A exact equation, which is S is equals to square root of I times P over 3131. So I, 40 inches, times P is the weight, 55 pounds, over 3131 is equals to 0.838 meters squared, which is the BSA. And then multiply the BSA by the given dose of the second basis. So it is 150 mg per meter squared. So multiply it and then cancel this one out because they have the same unit. Multiply 0.838 times 150 is equals to 125.7 milligrams. So again, in first basis, we have 125, which is left it into and second basis 125.7. Next, we are going to move on to problem number 4. So if an adult dose of the drug is 750 milligrams, what is the dose for a child weighing 25 pounds? So child. And since child is involved, we are going to use equations or the rule that has about calculation of child dose. So the given here is the weight. So we are going to use the Clark's rule, which has the equation weight in pounds over 150. So 150 here is constant, times adult dose, which is the 750, is equals to the dose of the child. And then just substitute it. 25 pounds 25 pounds over 150 times 750 mg. So 25 over 150 is equals to 0.166, and then multiply by the adult dose 750 mg. The answer would be 125 mg. That is the dose for the child weighing 25 pounds, given the adult dose of the drug, which is 750 milligrams. And lastly, the problem number 5, calculate the dose for a 3-year-old child. An adult dose of the drug is 500 milligrams. And then we are going to use the Young rule. So Young's rule is age, which is 3 years old, over age plus 12 times adult dose. And that is the dose for the child then. So substitute dose for child age, which is 3 years old, over 3 plus 12 times 500 milligrams, which is the adult dose. So the answer in 3 over 3 plus 12 is 0.2. Multiply it again by the adult dose, 500 mg. So the answer is 100 milligrams. That is the dose for a 3-year-old child with an adult dose of the drug of about 500 milligrams. So I think that's all for the calculation of doses. Thank you so much for listening. And I hope you learned something.